The United Kingdom looks like a small, unremarkable cluster of islands on the northwestern edge of Europe. You have probably seen the map 1,000 times. Familiar, green, easy to dismiss. Most people assume they already know this place, the rolling hills, the grey coastline, the predictable weather. But that assumption is exactly wrong. Because beneath those gentle hills, beneath the cold waters of the North Sea, and locked inside ancient stone at the edge of the Atlantic Ocean, is a geography so strange, so extreme, and so far outside what you expect that it rewrites everything you think you know about this country. Today we are breaking all of it down. The volcanic event 60 million years ago that left its signature on two separate shores across open water. The drowned landscape that lies right now beneath the sea between Britain and mainland Europe. The geological fault line that still helps explain with extraordinary precision why so much of Scotland's population lives where it does. The tidal phenomenon so powerful it is often described as second only to one other place on the entire planet. And the reason that the United Kingdom, a country smaller than France, stretches across a range of landscape, climate, and deep time that has absolutely no right to fit inside borders this size. By the end of this video, you will never look at Britain the same way again. And I promise you, the reality is far stranger than anything you imagined when you clicked. Let's start with the fact that should be in every textbook, but somehow never is. On the northeast coast of Northern Ireland, there is a place that looks like it belongs on another world entirely. Nearly 40,000 interlocking basalt columns rise from the sea, many of them hexagonal, stacked with a precision that looks less like geology and more like deliberate architecture. This is the Giant's Causeway. For centuries, the people who stood at the edge of this formation and stared at its impossible geometry could not reconcile it with nature. So they built a myth instead, the legend of the giant Finn McCool, who constructed a causeway across the sea to challenge a rival in Scotland. It is a compelling story. But the real explanation is more extraordinary than any myth the human mind could construct. Because if you leave Northern Ireland and make your way across the water to the tiny Scottish island of Staffa, you will find a closely related formation waiting for you on the other side. Matching hexagonal columns, matching dark basalt, rising inside a sea cave the Gaels called an Uam Bin, the Melodious Cave, and which later became known as Fingal's Cave. Two formations separated by open water, matching each other in geometry and rock type as though designed by the same hand. Here is what happened. Approximately 60 million years ago, as the North Atlantic Ocean was in the process of tearing open, a massive volcanic episode flooded the landscape with molten lava across what is now both Scotland and Northern Ireland. As that lava cooled, it contracted, and contraction forced the rock to fracture in the most geometrically efficient pattern possible. Hexagons, lava from the same wider volcanic episode cooled on both sides of the water that would eventually divide them. The ocean opened between these two formations over millions of years and still could not erase the evidence each one carries. The Giant's Causeway and Fingal's Cave are two surviving pieces of a single geological story, a story written in fire, then split by sea. Right now, beneath the North Sea, stretching from the eastern coast of Britain all the way to the shores of the Netherlands and Denmark, there is an entire world that was inhabited by human beings. Not in the distant geological past, not millions of years ago, 8,000 years ago, within the span of human communities whose descendants are still alive today. A world that people walked across, hunted through, fished in, and built communities within, before watching it disappear beneath the rising sea. Until approximately 8,000 years ago, Britain was not an island. It was a peninsula physically connected to mainland Europe by a vast low-lying plain of river valleys, marshes, ancient forests, and open grasslands. Geologists and archaeologists call this land Doggerland. It stretched across hundreds of thousands of square kilometers, linking the eastern coast of Britain to what is now Norway, Denmark, and the Netherlands, in a landscape that was, by the standards of the Mesolithic world, some of the richest ground in all of Northern Europe. Teeming rivers, dense forests, wetlands alive with birds, and people, Mesolithic hunter-gatherers who made tools, caught fish, and lived full lives on land that no longer exists above water. Sea levels rose steadily as the last ice age ended, and Doggerland shrank over thousands of years, its margins retreating, its rivers widening into sea channels. And while the flooding was driven mainly by long-term sea level rise, one dramatic event may have accelerated the crisis. Around 6,200 BCE, an enormous underwater landslide off the coast of Norway, known as the Storegga Slide, displaced a vast volume of seawater and sent a massive tsunami across the North Sea, striking what remained of Doggerland's low-lying coasts. For some communities, it may have been catastrophic. But Doggerland's disappearance was not simply a single-day apocalypse. The higher ground that remained eventually became the British Isles. Britain is not naturally a set of islands. Britain became islands through rising seas, retreating ice, and sudden shocks to the landscape. But while the sea defines the edges of the United Kingdom, inside the land itself there are older divisions, ones written not by water, but by stone. Scotland is split, not by politics, by geology. Running diagonally across the country from Helensburgh in the west to Stonehaven on the east coast is a structure called the Highland Boundary Fault, a fracture in the Earth's crust formed hundreds of millions of years ago. Stand north of this line and you are in the Scottish Highlands, a landscape of ancient, exposed rock, resistant to erosion, largely difficult for intensive agriculture, and shaped by ice into terrain that made easy settlement almost impossible for most of human history. Stand south of it and the land changes immediately. The central lowlands open up, softer rock, deeper soil, easier rivers, and the coalfields that powered Scotland's Industrial Revolution. Glasgow and Edinburgh both sit in the lowland belt. A large share of Scotland's population lives south of the fault. Running deeper still through the Highland interior is a second major fracture, the Great Glen Fault. This ancient fault line slices the country nearly in half along a remarkably straight valley running from Inverness in the northeast to Fort William in the southwest. The Great Glen Fault created a chain of long, narrow lochs that fill its valley floor. One of those lochs is Loch Ness. Approximately 37 kilometers long, reaching depths of over 230 meters, Loch Ness holds more fresh water than every single lake in England and Wales combined, not more than any individual lake, more than all of them added together. Now, if the interior of Scotland bends the mind, what happens on the border of England and Wales twice every single day challenges belief. The Severn Estuary, where the River Severn meets the Bristol Channel on its way to the Atlantic, experiences a tidal range of up to 15 meters, close to 50 feet. The shape of the Bristol Channel acts as a funnel, compressing the incoming tidal surge as the water narrows and shallows, amplifying it with every kilometre it advances inland. The result is one of the highest tidal ranges anywhere in the world, often described as second only to the Bay of Fundy in Canada. From this tidal force comes the Severn Bore, a wave built by the incoming tide that travels upstream along the river at speeds that can exceed 10 kilometers per hour. Surfers travel from across the world to ride it. Every year in the grey English countryside, people paddle into a river in Gloucestershire and surf a wave powered entirely by the gravitational pull of the moon. That is not spectacle. That is planetary physics playing out on an ordinary Tuesday morning on the English border. And then there is the question of what the United Kingdom actually spans. Draw a straight line from Lizard Point, the southernmost tip of mainland Great Britain in Cornwall, north to Outstack, the northernmost point of the Shetland Islands. That line covers well over 1,000 kilometers. The Shetland Islands sit at around 60 degrees north, roughly equidistant from Aberdeen, Tórshavn and Bergen. In midwinter, the islands receive fewer than 6 hours of daylight. They are a world of peat, Atlantic wind, and deep Norse heritage that feels closer to Scandinavia in both geography and character than to southern England. And yet they are part of the same country as the chalk downlands of Kent, the limestone gorges of Somerset, and the flat reclaimed fenlands of East Anglia. The United Kingdom contains, within borders that look modest on a world map, a geological and climatic range that takes most countries a continent to achieve. That is the hidden geography of the United Kingdom, a country whose land was physically joined to Europe 8,000 years ago and severed not by drift, but by rising seas, retreating ice, and sudden shocks. split by fault lines that still decide where cities are built and where wilderness survives, home to matching volcanic fingerprints on two different shores of the same open sea, left there 60 million years ago, subject to tides so extreme they rank among the greatest on Earth. Stretching from near Arctic islands to mild southern coastlines across a distance most people never stop to measure. The United Kingdom looks small on a map. But it is ancient beyond imagination, strange beyond expectation, and shaped by forces that have not yet finished their work. If this changed the way you see a place you thought you already understood, subscribe now. Because every video we make uncovers the hidden geography behind the places of the UK. Hit subscribe, and we will see you in the next one.